Okay, so we are going to use the data set heavy metal music and suicidal risk. That's two variables, and they're both represented by scores. The model that we are going to use will establish if we can predict if suicidal risk can come from listening to heavy metal music. So first, in the data set, we're going to remove the missing values. We're going to go to data, select cases, and then if we go to missing values, and we're going to use that function, and we're going to do that on both variables here, and then we're going to do less than 1, and then we're going to continue, and then what we're going to do is we're going to delete those unselected cases. Click on OK, and the data has been removed. So that's the first thing we're going to do. Second thing, we're going to look at scatter plot. So we go to graph, scatter. We're going to do the simple scatter, and we are going to, dependent variable is suicidal risk, and our independent is listening to heavy metal music value, and then click on OK. So there is the data we have, and we can add a regression line. There we go. So what we can see from that chart is it looks like the data is linearly related and negative, the regression line. So the meaning of that is that as we listen to more heavy metal music, the suicidal risk decreases. So we are next going to, we're going to get out of that, check on the assumptions that we have. First, it looks like our data is linearly related, that we saw in the scatter plot. And then it also looks like we have almost staticity, since the data spread on each side of the regression line appears to be similar. So moving on to data analysis, we're going to go to Analyze, Regression, Linear, and then we're going to move a dependent variable here, independent variable here. On statistic, we are going to get a confidence interval of 95. We're going to do descriptive data, and then we're going to click on get the Durbin-Watson residuals and case-wide diagnostics. And OK, on plots, we're going to why we're going to get what Z residual, it's residual errors, and X is the predictor. There it is. And we're going to select histogram and normal probability plot, continue, and then we're going to stop here and then wait for the results. So first we're going to check another assumption is we're going to look if we have outliers or not. And for that, we actually go to the residual box, and the standard residual really should be between negative 3.9 and positive 3.9. So it looks like we might have some outliers on the maximum side. decided to keep the data set the way it is, and we will make sure to mention that in the result page. Then we look at the Durbin-Watson score, and it's 1.994, which is good because it needs to be between 1 and 3 and close to 2, which is exactly what you have to show that we have an independence of observation. So that has been verified. Then we look at normality. So we go down to the PP plot, and we see that the data is scattered around a 45-degree line. So then to complement that, we look at the histogram, and we see that it's slightly skewed to the right, which is probably due to those few outliers, but as a general, we really do have a normality of our data set. So then we're going to move to the interpretation of data. So we have descriptive, so those are the means that we're going to use in the results. The Pearson correlation that we use, we see that it's a negative 3.53, which reinforces the fact that we have a negative correlation, which is the negative line of regression we were looking at earlier. Then in the table below, variable entered and removed, those are just kind of letting us know what variables we are using in the analysis. Then in model summary, that's where we have our R, which is the similar number as the Pearson correlation, and then the R square, which is a coefficient of determination. And then we can interpret that as saying that 12.5% of suicidal risk can be predicted by the level of heavy metal music that's being listened to. So then we move to the ANOVA table, which is another way to look at the regression model. And the sign, the significance value tells us that our model with one predictor works better than just using the means. And also that the model using listening heavy metal music as a predictor was significantly better than prediction without that predictor as well. So those are the conclusion we can draw from the ANOVA table. Then moving on to the coefficient table, that's where we are going to see how the model works. So we're going to get from the understandized column a constant and a b-value for the equation. And then the interpretation of that table is that for every 1 unit increase in listening to heavy metal music, which is the predictor, the suicidal risk will decrease by 0.612. That concludes the analysis of the linear regression. Thank you.